4-8. I have, I guess, what I call the condensed version for you today. 4-8 has 6 main topics. So you can see I went through and I highlighted each one. My goal is to get this all done in the next 45 minutes. No lesson should take more than 45 minutes as long as you're cooperating with me. So if you guys can do that, I'd very much appreciate it. All right, again, this is the very short abbreviated version to what is called complex numbers. Okay, complex numbers. The introduction to this lesson is that we have always known numbers to be, well, normal. Maybe 1, 2, -1, -2, square root of 3, negative square root of 3, 3/4, -3/4. But you've never learned about the I. An I is a number, and it represents the square root of -1. If you ever had the square root of -1 before today, you would just say no solution. In fact, you would say no real solution. Just so you know, if I is the square root of -1, that makes I squared equal to actually -1. Not so because you would have a double square root and a double square root cancels. All right. Part 1, how do we simplify square roots with negatives, and how do we do that using imaginary numbers? Now, what is the square root of 64? 8. So the only difference is this negative, we would say it is an imaginary 8. So because it's really like the square root of -1 times 64, it would be 8 times I, or 8I. Now one that does not reduce. There are no perfect squares inside of 35. So we're just going to take the I, put it right here. That's from the negative sign. And you leave the square root of 35 behind it. Miss Miles will say, take your eyes out, but don't go blind. This one reduces. Does anybody know the perfect square that goes into 48? Remember that list that we were using before? Does anybody remember what perfect? No, those, well, 4 is a perfect square. There's a bigger perfect square that goes in to 48, and it is 16. So what we're going to do here is we're going to write 48 as -16 times 3. The square root of -16 is a 4 with an I. And the square root of 3 travels down behind it. So the -16 turned into a 4I. So if there's a negative on the inside, bring out an I. Does anybody using the same list know what goes into 180? What on that list of these highlighted numbers goes into 180? I will tell you it is smaller than 49, but it is bigger than 9. Just to kind of speed, it is 36. Does anybody know it's 36 times 5? So what do you guys think? What does the square root of -36 become? 6 with an I, because of the negative. And then the 5 is inside. Okay.
So that's only if we did negative 4.
Correct. Otherwise, it would just be 6 squared to 5.
What if we they used I's instead of X's for whatever reason?
You can treat it the same way. You can, like, if you have 2 I's inside, you can pull out one. Do you have an example that you want to ask about? Like, if it looks like what? Give me an example.
I don't know.
Okay, if you think of one, because maybe I'm not understanding your question. If you think of one, like, hey, what if it looks like this? Write it down. I is a negative on the inside. Yep, negative on the inside makes I on the outside. So that was part 1. Part 2, how do we add, subtract, and multiply? Notice what's missing. Right now, I'm just going to do these 3. What's missing? Add, subtract, multiply. Yes, that's its own whole section. So how do we add, subtract, and multiply with imaginary numbers? Well, let's talk about the easy one, adding and subtracting. So I didn't mean for that all to be on 2 lines. I apologize. I'll write it like this. It's 2I, take away 4I, plus, are you guys okay if I make that 15I? Can you see that I made that into 15I? And now we just combine our like terms. So 2 minus 4 is -2, plus 15 makes 13 with an I. Now, if there was like a random +6 in the back, the answer would be 13I plus 6. I'll email you. Okay, thank you. So if there was a random +6, you can't put the 6 with the I's. It's like, it treated kind of like an X. You just combine your like terms and bring them down. Part B, Let's see what I wrote up here. How to multiply a binomial by a monomial. So we're going to do this. 1. That is correct for the first one. Plus 6. That would actually be 6i squared. Do you guys see the I squared from the second arc? It would be an 3i times a 2i is 6i squared. Now, way up here at the very beginning, remember what I told you I squared was? I squared is a -1, yeah. So I need to go back to this, and you are correct in telling me that it was 16i squared? Yes. So this turns into this. I want you to have it memorized, if you could, please. This would be very important. I squared is -1. So I'm replacing my I squared with a -1. So I finish with -15i, and that's take away 6. This is called a complex number because it's made up of an imaginary part and a real part. That's what makes something a complex number. It has an imaginary part and it has a real part, and you can't put those two things together. Final answer is there. Remember, I squared is -1. So, okay, we did that, but now how do we multiply with binomials? So let's do the two arcs of this one. What does that make when you multiply? Just that single arc, please. What's that? -4. What does this single arc make? Good. For a negative, and then an 8, and then an I. Come and change colors. What does this one make when you multiply? -3 with an I. And what does that arc make when you multiply? -6i squared. Now we're going to combine our like terms, and we're going to turn your I squared into a -1. Hello, it's Amy Langeli. Okay, so we are going to combine our like terms now. We're going to combine our like terms here, and we need to change our I squared into a -1. So it's a -4. That's a -11i, and that's going to be a -6 times a -1. Can you guys see how that I squared became into a -1? I squared is -1. So this is really -4 minus 11i plus 6. So that's really a +2 minus 11i. Nope. In fact, I would prefer if the real was in front, but I will accept either. Okay. The last thing that's kind of difficult to wrap your brain around that we'll talk about, and then if you get it, you get it. If you don't, then it's only one on the test that you'll miss. All right, here we go. Remember, I to the first power is just I to the first power. There's nothing more you can do to that. All right. I squared, what did I teach you I squared was? -1. I hope that you have your Algebra 1 skills with you enough to know that I to the third is made up of I squared and I. You learned in Algebra 1 that you can separate exponents by adding them. So that's a double I plus a single I makes a triple I. Now, the reason I wrote it like that is because I squared is -1 times I equals a -I overall. So I separated my 3 into a 2 and a 1. I made my I squared into a -1, and I put my answers together to make a -I. Notice in the directions I quickly wrote, answer will never end with anything more than I to the first power. Now, I to the fourth. Your Algebra 1 teacher taught you that I to the fourth is the same as I squared with I squared, because 2 and 2 makes 4. So that's really a -1 times a -1, because I squared is -1, +1. Or, yeah, +1. So this chart that I'm about to show you, if you don't understand it, I ask you maybe stay after and I'll try to explain it a little more. We'll talk about it again tomorrow. Let's say that you have I to an odd power. Versus I to an even power. Trying to think what my chart looks like. If your even power divides by 4 with no remainder, then the answer will just be a +1. If your even power divides by 2 only, but not by 4, then your answer will be a -1. So even exponents will either be a positive or a -1. And you can see that represented up above. There's an even exponent being a negative 1. There's an even exponent being a positive 1. And the difference is if it divides by 4 or not. Odd. Odd or trickier. If your odd number, you have to do your odd number and you have to subtract 1. If it divides by 4 then it's a positive I. If you take your odd exponent and you subtract 1, and it only divides by 2, but not by 4, would you guys like to take a guess as to what the answer would be? A negative I. We can practice that more as a warm-up tomorrow, but that's kind of like the nitty-gritty of how all of those work. So I think the test question is something like, hey, what's I to the 15th? Okay, so I'll just do one of those real quick. I to the 15th. Well, that's odd, right? So I need to do my odd exponent take away 1 makes 14, right? So does 14 divide by 4 or only by 2? Only by 2, right? So because it's odd and it only divides by 2, it would end up being a negative I. If that was a lot to take in, feel free to see me after class and we'll go over a couple more of those. All right, let's go on. I have 33 minutes to get through the next 4 parts. We've only gone through 2 parts. There's 6 parts altogether. Okay, on this one we did add, subtract, multiply, divide. Add, subtract, multiply, divide. I'm sorry, we did add, subtract, and multiply. Now it's time to do just division. How do I divide with these imaginary numbers? Remember, I is the square root of -1, okay? You can't have square roots in the denominator. Whether you remember that from Algebra 1 or not is beyond my guide. I don't know if you remember that or not. You can't have square roots in the denominator. So does everybody see that I right here? This is not allowed. That's like not reduced because it's a square root in the denominator. I want you to read this word, monomial. And you see this circle, that green circle, the bottom green circle? That is a monomial. There's no adding and subtracting. Now, they're making a big deal about it because you handle monomials differently than you handle binomials. If it's a monomial, you multiply top and bottom by I. It is going to get rid of the I in the bottom when you do this. Technically, does anybody know what I'm technically multiplying by? I over I is actually 1 over 1. You can multiply anything by 1 and not change it. If I multiply my weight by 1, I'm still the same weight. So it's like you're not changing the problem, you're just changing its form. We are going to do these 2 times each other first. My green highlight, what do I get if I multiply those 2? Green highlight, what do you get if you do 7i? That is correct, you get 7i squared. All right, now I told you that would make the I go away. Well, it will, because what is I squared? -1. And what's 7 times -1? -7. So this is called rationalizing. We rationalized this problem. We got rid of the I on the bottom, but we still had to do the top. So let's go to the top. Let's draw parentheses around our binomial. If you're not sure what I mean by that, take a look at the board. That's a binomial. Draw 2 distribution arcs. Here's your first arc. Here's your second arc. What do you get if you distribute with those arcs? What does the first arc give you? 5i. I times 5 is 5i. What about 3i times I? 3i squared. What did I teach you about I squared? Okay, so this is really 3 times -1. My last, well, almost last fraction will be 5i. What's that going to do to the 3? -3. There's this really cool rule in math that negatives don't belong in the bottom. So we have 2 options. You guys pick either one that you want. I don't care which way, as long as you know they're both equivalent to each other. You can either distribute the negative through the top like this and put it over a +7 like that. So you can distribute the negative through the top like boop, boop, and then get rid of it on the bottom. Or you can simply just put it in the front of your fraction and not distribute. But whatever you do, don't keep it in the denominator because that's not where it belongs. Now that was a monomial. It's time for me to teach you to do now with a binomial in the bottom. When you look at the bottom, what are you typing over there? When you look at the bottom here, you'll see a binomial, meaning it's separated by addition or subtraction. So this is a binomial, so you have to do it differently. You have to use a funny phrase. It's called the conjugate or the conjugate. I always call it conjugate. It has an A in it though. Here's what the conjugate does. You multiply by this denominator, but the conjugate changes the sign. Multiply by the denominator, but change the middle sign. That's called the conjugate. I'm going to write that. Conjugate. I probably say it wrong because it has an A in it, but that's called the conjugate. All right. We are very slowly going to do one arc at a time. And I think I'm going to do it slow enough that everybody can keep up. If that's not the case, please ask. Okay? Sure. This fraction always has to be the same thing over the same thing. And I had to pick what to do. So you have to change the middle sign of the bottom. So if you see two things in the bottom, pick those two things, but change the middle sign. And it always has to be the same on the top. All right, very slowly. I'm going to get rid of all of these words because I want to see all of my arcs. Very slowly, we're going to put parentheses like this, and you guys are going to distribute one at a time. Here it goes. First one, say it out loud once I connect. Are you guys ready? 3 times 3 makes. Okay, that was the first one. 3 times 2i makes. I'm going to change colors because sometimes it gets confusing down there. Negative 2i times 3. Negative 2i times positive 2i. Good. If you do that slowly, you'll probably be okay. Next, I need you to see that these cancel. That's why we had to use the conjugate. If those don't cancel, you did something wrong. I also need you to see, you paying attention back there? Okay. I also need you to see that this is really a minus 4 with a negative 1 because I squared is negative 1. And if it's a negative 4 with a negative 1, what is it really? A positive 4. So your entire denominator is actually a 13. Do you see where I got 13 from? What gave me 13, please? The blank and the blank. Good. Okay, so we did the bottom. Now it's time to do the top. I'll use 2 different colors again. Or actually, I just think I need one. Put parentheses around your binomial. Very slowly. If I say it, I think you'll know it. What is 4i times 3? What is 4i times 2i? 8i squared. What is I squared? So this is really plus 8 times a negative 1, which is really just what? A minus 8. Can you put the 12i and the 8 together? Nope. They're not what? What's that phrase? They're not like terms. If you wanted to, you could divide these. Do they reduce? Like, does everything divide by 2? Does everything divide by 3? Okay, then we'll just leave it as it is. If nothing divides out, then leave it as it is. If you want to separate it to 12 over 13i minus 8 over 13, go ahead. Both of those are perfectly fine answers. Okay. That was part 3. I have 2 more of those. If we have time for them, we'll come back to them. I tell you what, let's just do this much of them. What do you guys think you'll multiply by on C? Take a look at what's that? Not 4i, just I. We can come back to that if we need to. You would have to work that out just the way it's the same as A. What do you guys think you would multiply by in part D? D as in dog. And you're close.
I minus 5.
I minus 5. And that's called the conjugate. So whatever the denominator is, you do the inverse. Okay. If we have time, we'll definitely come back and do those because this is kind of a new concept. Definitely a new concept. Part 4. How do you solve using imaginary numbers? Well, when we solve for x, did anybody remember what was our favorite method for solving for x in this chapter? We had, yes, set it equal to 0. Now, and then we could pick, did you want to factor it? Did you want to complete the square? Or do you want to use the quadratic formula? What way worked all the time? And I think that would just be the best way. But like you said, yeah, you got to get it equal to 0. You should all know the first step to solving this one. What should we do first? Search for the D. Distribute. What do you get? Equals -5. And then I heard you say set it equal to 0, which is correct. How do we set this equal to 0? Okay. So that would be 2x squared minus 6x plus 5. And yeah, there's nothing different so far from what we did back in chapter 4, section 7 here. In fact, we can still find A, we can find B, and we can find C. A, B, C. And we can do our whole formula. I don't want you to change anything. I just want you to see how imaginary numbers are used. Okay, I'm going to erase negative B. What should I put in there? +6. Good. Now, what do you guys think I put in for B squared? What do I put in for B squared? -6 squared, yep. These were the tasks that we did on the past 2 days of school. What was that, Wednesday and Thursday? What goes in for A? What goes in for C? And then the denominator, again, put in a 2 for A. Nothing is different. You guys should say this looks very similar to what we were doing on Thursday. Good, it should. Okay, so we're going to get x equals 6 plus or minus. And I can type it in a calculator, but I mean, I already know how to, so I'm hoping you're all picking up your calculator. Let's see, 36 minus 40. I think I have it, but I don't, is it -4? That's what I got in my head. Can I have one other person with a calculator confirm? Thank you. All right, so there's my -4. And hopefully because of this negative, you can see why this is an imaginary problem. That's why. Like, imaginaries help us solve problems when we get a negative inside the square root. So we'll write x equals 6 plus or minus. Does anybody remember the square root of 4? 2. And then what about the negative? I. So because we had a negative on the inside, we have an I problem. And now we're going to divide everything by what? We can divide everything by 2, or you can separate it and divide it by 4, whatever you want. Okay? So do you want, we can do 6 over 4 plus or minus 2 over 4i, like that, and reduce. It's fine with me. Or you can just, what you said, you can just divide everything. That's 3 over 2 plus or minus 1 over 2i. And other than just putting an I on our answer, nothing is different than Wednesday and Thursday on that part. I'll say that sentence again. We're putting an I on our answer. Why did we use an I? Because we had the square root of a negative. Other than that, it's the exact same as Wednesday and Thursday. So if you're like, boy, that was really hard, then I'm guessing Wednesday and Thursday were very hard for you. Okay, what should we do here? Yep, get it to 0. So let's add 5. X squared, take away 4x plus 5. We have 20 more minutes to get through the next 2.5 parts. We're doing okay, though. And I would love to come back and do those monomial and binomial problems again. What is A? I know it's hiding, but does anybody know what A is? Do you remember? 1. So I'll do A, B, and C. A, B, and C. And big fraction bar, x equals opposite B plus or minus square root B squared. Oh no, I'll need parentheses. 4AC, 2A. If some of you did not get -4 in the previous problem, I would like to suggest that maybe you forgot your parentheses around your -6. All right, so what am I going to replace -b with? +4 plus or minus. What am I going to replace this squared thing with? Keep going. +5 over 2 times. Good. All right, grab that calculator. I can do this in my head, but I would prefer if you guys check it in your calculator just to make sure we're all on the same page. I haven't redone these. This is my first time redoing these notes in a long time. 16. I want to get the same thing, but that's okay. Darn it. If it was anything but I did not want to get -4 again. Oh well, I chose poorly, but it is what it is. I was hoping to have something different there, but that's all right. Well, what did we say in the previous problem that -4 was? Yeah, 2i. I saw some like questioning looks here. I feel like this was hard for kids. The next step. What should we do here? What would be next? Remember? Yeah, so it's 4/2 plus 2/2 with an I. So this is 2 plus or minus 1 I. You don't need the 1. If you don't want the 1, you don't need the 1. I would just like to ask a question. And I had to redo these notes in about 15 minutes. What if we would have got the square root of -48? I know we didn't, but what would we have done if we got the square root of -48? Do you remember? You would use the thingy. Yes. You would have to use the squares. And what would that turn into? This is just if. If, yep, but you would need an I because of the negative. Okay. So if for some reason, if we would have got or gotten, I don't know. I teach math. If we would have got -48, we would have had to have kept going like that. Just FYI. Gotten, got. Does anybody actually know? That's fine. We're in math class. We can say whatever we want. Okay. Part 5. How do you graph them and how do you find their absolute values? Well, I can say whatever I want. Okay. Complex number. So this is, if any of you like reading math, there it is. There's a complex plane and a real plane. You guys are very much used to this. What's this axis right here? To you. That's the x-axis. What's this axis? The y. Well, that's how you graph in the real plane. But unfortunately, there's a complex plane. What you think of as the y-axis is the imaginary axis, and what you think of as the x-axis is the real axis. So in a complex number, this is called a complex number. When it's just a dot. Electrical engineers would use this as they progress through their education. So this is your real axis, and this is your imaginary axis. So what do you guys think I do with this 5? Do you think I go up, down, left, or right? That is actually not down 5. It goes on your real axis, and it's negative. So which way do you think we go? Left. So we go 1, 2, 3, 4, 5 in the real direction. Oh, I shouldn't put a dot there. And what do you guys think about this? Should I go up or down 3? On your imaginary axis is positive, means up. So this right here, just that dot is the answer. That's the graph. There's a test question, and I hope you guys agree that's probably not too hard, but it's so easily forgotten. Sometimes it's like easy information in, easy out. So that is a test question. It's not hard, but you do have to review it. And there is an absolute value of it. So here's what we do. Here's what it will look like on the test. This is exactly what it will look like with different numbers on the test. So those straight bars mean absolute value. And here, I don't know if any of you are interested in becoming electrical engineers or anything, but what we're going to do, you see this line right here that I just drew in blue? What I'm about to find is the distance of that line. I hope you guys can see a triangle that's being formed, and I hope you're going back to geometry class and thinking a squared, b squared, c squared, or the distance formula. But if you're not, don't worry, I got you. Here's how you do the absolute value. And if all that didn't make sense, all you have to do is look back at your notes and do this on the homework. Draw a square root. Square the 5. Don't even worry about the fact that it's negative. Square the 3. Don't square the I. A lot of kids say, hey, you forgot the I. Nope, nope, nope. You're just concerned about the numbers. What is 5 squared, please? And what is 3 squared? And what is 25 plus 9? And if I used my chart, I don't know where that went. Does anything on this chart go into 34? Do any numbers on this chart go into 34? Yeah, other than 1, nothing, right? So its absolute value is the square root of 34. So let's just make sure if it asks for the absolute value, this is the process you do. Step 1, step 2, step 3. And if there's a step 4, you reduce it. That's the absolute value. It's how far away that dot is from the origin. So it would be like 5.8 units away from the origin because the square root of 34 has got to be pretty close to 5.8. All right, let's see if you guys can repeat that. This is called a pure imaginary. Does anybody? Yeah. Can anybody guess why this is called a pure imaginary number? That's right. You don't have any real numbers. If I was like, no, you have to have a real number, just make it 0, okay? What do you guys think the graph of this would look like? Remember, this is your real axis. This is your imaginary axis. Just up 6. That is correct. Yep, I stands for imaginary. Yep. That's the graph. The absolute value of it is the square root of 0 squared plus 6 squared. And if you're like, I don't want to write that 0, that's dumb. Okay, don't. That's totally fine. I agree with you. 0 squared is useless. So it's really just the square root of what? It's the square root of 36, which equals a perfect 6 overall. And I hope that makes sense because that dot is surely 6 units away from the origin. So we have made it through parts 1, part 2, part 3, wow. I'm just going to say parts 1 through part 5. Okay, sorry about that. How do you factor? Now, believe it or not, factoring with them is pretty easy. Okay, that means we probably have time to go back and look at the more difficult part of the lesson. Here we go. How to factor with imaginary numbers. All right, I have tried my darndest with you guys to get this phrase through your head. Does this phrase ring a bell? Difference of perfect squares? Okay. No, seriously, you don't remember? This is difference, and these are perfect squares. So instead of doing the whole A, C, B, and the box and yada, 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 I taught you there's a shortcut you can take. First of all, check, is there a GCF? Just one, right? Okay, so I'm not even going to bother with it. To factor it, you would do the square root. What's the square root of my first circle there? Here, let me do it again. I'm sorry, because there was a lot of circles going on. What's the square root of that? 2x. Put that there and there. What's the square root of this one? The second one? 5. Put it here and here. So again, you can go through that whole ACB chart, make the box, find the GCFs, yada, yada, yada. This is a lot easier. You do their square roots. Do you guys remember what your signs are? One is A and one is A. All right. So you might say, okay, why did you do that? I don't see any imaginary numbers at all. You're right, you don't, because difference of perfect squares doesn't involve imaginary numbers. But you see this word here, sum of perfect squares will involve an imaginary. Okay, I have 11 minutes to do this. Here we go. I want you to see where this phrase comes from. Here it goes. Sum. You guys see the plus sign means sum, and these are perfect squares. If you try to do your ACB chart, nothing ever would work. So let's go ahead and just go straight to the factoring. It's the square root. I'm not changing the rules. I'm not changing the rules at all. It's still the square roots. It's still 1 as a plus. It's still 1 as a minus. However, because it was the sum, you see this adding sign? These 5s need imaginaries. You do not have to do this, but for anybody who's like, You just taught me something that doesn't make any sense. I want to teach you why it works. If you don't accept it, that's totally fine. Here's why. Okay, if you don't care, then you don't have to pay attention, but here's why it works. 2x times 2x is 4x squared. 2x times, that's a negative 5xi. Oh, 10, isn't it? Negative 10xi. That's positive 10xi. And that's negative 25i squared. These go away. And this is a negative 25 times negative 1, which turns into a positive 25, which proves that if you factored them, you would get the sum of perfect squares. If that was too much, that's totally fine, as long as you can memorize that they're the adding and subtracting of the square roots, and you put an I on it. All right, let's do one more difference of perfect squares. But before we do, somebody tell me what the GCF is. Tell me you know the GCF, kids. Does 36 go into 400? Check it out. Somebody check it out. 40. I thought not what I had planned on making the GCF on this problem. I planned on it. It doesn't. It does? What is it? 16? 16 doesn't go into 36. I think I made it 4. I honestly think when I made this problem, I want to know what goes into 36 and to 400. What is it? I think it's just 4. I think it's just, when I did this in my head, when I made this, I tried to make the GCF a 4. I hope I accomplished that. If I divide this by 4, what do I get? 9x squared. What if I divide this by 4? Say it again. Negative 100. All right. Bring your GCF down. Do a double parenthesis. Let's see if you guys can get what their square roots are. One's going to be a plus, one's going to be a minus. What's the square root of 9? So this is going to be a 3x and a 3x. What's the square root of 100? Do these ones need eyes? Nope. Because this is a minus sign right here. There, yeah, it's a difference of perfect squares. You're done there. Now what we're going to do is we're going to compare that to the exact same problem, but look what I did to the middle sign. I just made it the sum. So let's take out our GCF of 4. That should always be step 1. It's still going to be 9x squared, and it's still going to be 100. Bring that 4 down. All right. What's the square root of 9x again? 3x and 3x. What's the square root of 100? 10 and 10. Plus and minus. And I heard you say these ones need eyes. Why do these ones need eyes? Because it's the sum of perfect squares. I told you that if I finished on time, which we did, I wanted to go back and I wanted to do those last 2 division problems I didn't get to, because I think this is what's going to trip kids up the most. Let's go back to, it's on page 2, part C. I'm highlighting what we're trying to get rid of. What are we trying to get rid of? The I on the bottom. Very good. This is does anybody remember the word I used for this denominator? It is a monomial. This is a monomial here, so we just multiply by I over I. Do you remember when I did this problem up above, did I do the entire denominator first or did I do the entire numerator first? I did, and that's to make sure I don't screw it up. Okay, so what is 4i times I? 4i squared. Okay. Well, what did we learn I squared is? No, I squared is negative 1. What's 4 times negative 1? Okay. Let's do the top now. What is 3 times I? 3i. Is that 3 times negative 1? Question mark? No, because only if it was 3i squared. Okay. So that's done. Do negatives belong in the denominator? No. So you can put it in the front, or you can just distribute it through the numerator. You decide. Just please don't keep it in the denominator. Okay, last one. Do you remember the fancy word for this right here? When you change the middle sign, it starts with a C. Conjugate. And you do that when there's a what here? What's that word? Starts with a B, binomial. Very good. If this is a binomial, you use the conjugate. Let's see how you guys do with that, okay? The first thing I had you do was put on parentheses in the last problem. How many arcs will the denominator have, please? I'm sorry, how many? 4. What is I times I? What is I times negative 5? What is 5 times I? Last one. What is 5 times negative 5? Okay. Let's continue to work through that denominator. What do you notice about the middle two items? And if that doesn't happen, you did something wrong. We'll do the top. No, the top two never have to cancel out. I can be in the top, it just can't be in the bottom. Can you guys remind me, please, what did I teach you today that I squared was? Negative 1. So our denominator is negative 1, take away 25, which is what? We'll deal with that negative in a second, but let's go deal with the top first. How many arcs do you think we're going to have on the top? Yeah. Let's do this one first. What's that arc make? 4i squared. What does this arc make? Not negative 20i. Good, good, good. Okay, change colors just because it's getting a little crazy up there. What is, those are pretty much the same color, Amy Langeli. All right. What does this arc make, that green arc? Positive 2i and negative 10 is correct. All right. What did we learn I squared is? Negative 1. Well, what's 4 times negative 1? Okay. So this is really our numerator. Kind of messy, but I tried to clean that up a little bit. Do you see any like terms? That is correct. We have negative 20i and positive 2i. What does negative 20i and positive 2i? That's really hard to read. I apologize. Did not realize how hard that green would be. I'm going to ask that again. I'm sorry. What does negative 20i and positive 2i make? Negative 18i. And what about last? What about this negative 4 and this negative 10? Okay. Last thing we should do is reduce. Do you guys know that all of this reduces by a factor of 2, right? Everything divides by 2? Okay, so we're going to cancel out everything by 2. So we'll have negative 9i minus 7 over negative 13. That's right. You can either just move the negative into the front like that. That would be okay. Or better, I think, is distributing it through. So I will highlight this as one potential answer, but I will also write, I will distribute it through the top because you'll probably see that more on the test than the other one. And that is complex numbers in a nutshell.